All right, we're continuing on with chapter 6 and lesson 6.5, which is solving exponential equations. So let's take a look at this lesson. So when we're solving exponential equations, if we take a look here, we want to have the two bases equal to one another. So if we look at it right in here, we can see here we've got if 2 to the x is equal to 2 to the fifth, then x is equal to 5. So what we're doing is we're setting the exponents equal to one another and we're solving. Now, the key thing when you're doing this is that the bases have to be the same. So two powers with the same positive base b, where b is not equal to 1, are equal if only their exponents are equal. Key things here, b has to be greater than 0 and b is not equal to 1. And then b to the x is equal to b to the y if and only if x is equal to y. So all we're doing is we're setting the exponents equal to each other as long as the bases are the same. So let's take a look at a couple examples in here. So in example number 1, we notice that we have the same base of 3. So if we have the same base of 3, we're just going to set the two exponents equal to one another. So x plus 1 is equal to 5. And then we're just going to solve for x. Subtract 1 from both sides, and x is equal to 4. In our next example, you'll notice that there's no exponent written there with that 6, but we know that there's no exponent written there. It's really raised to the first power. So we're going to rewrite it as 6 to the first is equal to 6 to the 2x minus 3. Again now, we set our exponents equal to one another. So I'm going to set 1 equal to 2x minus 3, and then I'm going to solve from there. So 1 is equal to 2x minus 3. And now we need to solve a basic linear equation. So we're going to add the 3 to both sides. We're going to get 4 is equal to 2x. Divide by 2. And x is equal to 2, or 2 is equal to x. So it's pretty easy on these ones because our bases are the same. Slightly more challenging here, but again, just set the two exponents equal to one another. So you're going to get 3x is equal to 2x plus 3. Let's solve for x now. This one works out nice and easily because you get 3x minus 2x, which is 1x or just x. So 1x is equal to 3. If you want to think about this dividing by 1, that's fine. But you're just going to get x is equal to 3 as your answer there. So these are all nice because if you've noticed on each of these problems, our bases are the same. So when your bases are the same, it's really easy. We have 3 and 3, 6 and 6, 10 and 10. Those are really easy to do because we can just set the exponents equal to each other and solve. Save the try these for class. Now let's take a look at these. These are significantly more challenging because in these problems here, your bases are not the same. We have a 5 and we have a 125. We have a 4 and we have a 2. We have a 9 and we have a 27. So what you want to do when you have a problem like this is you want to look at the larger number. So we're looking at the larger number. And you want to try to rewrite the larger number with a base of the smaller number. The goal here is that you must have the same base. Sometimes you have to rewrite both of them. So we're looking at 5 and we're looking at 125. You want to think to yourself, okay, how can I rewrite the larger number, which is 125, to have the same base as 5? So I have 5 to the x, and then I say to myself, wait a second, I know that 125 is equal to 5 to the third. So if I rewrite 125 as 5 to the third, now I have the same base. I have a base of 5 here and a base of 5 here. So I've rewritten my 125 to a base of 5. Now I can just set the exponents equal to each other. And this is a nice and easy one here. Set the exponents equal to each other, and you're going to get x is equal to 3. And you don't even have to go any further because x is solved for, and you're done with the problem. Let's look at our second one. So we've got a base of 4 and we have a base of 2. So I start by looking at the larger number, which is 4, and say, is there any way I could rewrite 4 as 2 to some power? And I can, right? 4 is equal to 2 squared. So I'm going to change that 4. I'm going to make it a 2 squared. But notice here, we have 2 squared, but we still have that exponent of x on the outside. So I have to raise it to an exponent of x. These are why your exponent properties are so important, because you have a power raised to another power here. And all this is equal to 2 to the x minus 3. So what are we going to do here with these exponents? We're going to multiply them. 2 to the x is equal to 2x. So we're going to get 2x is equal to, what's my other exponent? X minus 3. Now solve, subtract the x, cancels there. 2x minus x is just equal to negative 3. So x is equal to negative 3 there. So see how that one was a little bit more challenging, okay? But again, you're always looking at the larger number, saying, is there a way to write it in terms of the smaller number? And that means raising it to an exponent. Now, if you look at this one, you've got a 9 and you have a 27. But if I think to myself, I say 9 to the first is equal to 9. Is there any way to raise 9 to some power and get it to be 27? And there isn't. So now I have to rewrite both in terms of a new base. So I have to think of a common base that these two, 9 and 27, have. And hopefully you're thinking to yourself, what about 3? I can rewrite 9 as 3 squared. Oops, I want that squared on the inside of the parentheses. And I can also rewrite 27 in terms of a common base. Don't forget what's on the outside of the parentheses. So 3 squared is 9. And if I go 3 cubed is x, or is 27 rather. So I've rewritten both of them in terms of a common base of 3 here, because there was no way to write 29, or 27 rather, in terms of a base of 9. Tricky part here, and that's why this one is in particular challenging, is this 2 you have to distribute to both parts there. So when I distribute that 2 to the x, I'm going to get 2x plus 4 as my exponent there, equals 3x as my exponent here. So again, tricky problem here. 2x plus 4 is equal to 3x. Let's solve for x. At least the equation's easy to solve. That'll cancel here, and 3x minus 2x is just equal to 1x. So 4 is equal to x. And you can check all your work on all of these guys by plugging it back in and seeing that you get the same answers, which you would. So sometimes you're going to have to rewrite both of your equations in terms of a common base. Sometimes only one side needs to be rewritten in terms of the common base. Here's 2 more to do, and now we're going up even another step. Okay, we have 1/2 raised to the x is equal to 4, and we want to determine how to rewrite that as a common base. So if I take a look at this one, we know back to our negative exponent rules. When I have 1/2 raised, or when I have something in the denominator, it's really raised to a negative exponent. So I'm going to start by rewriting this as 1/2 to the x is equal to 4. And if I raise it to 4 to, say, the negative 1 power, I know that that's going to be equal to, oops, hold on. This is really 4 to the first. Sorry. Okay, so this is what I'm at right now, but obviously I don't have a common base. But I know that I could rewrite 1/2 as 2 to the negative first. Okay, so 2 to the negative first is equal to 1/2. So now I'm going to rewrite this as 2 to the negative 1 times x. And how can I rewrite 4 in terms of a base of 2? Well, I can rewrite 4 as a base of 2 as 2 squared. Set my exponents equal to each other now, common bases of 2. So I'm going to have negative 1x is equal to positive 2 rather, divide by negative 1, and you're going to get x is equal to negative 2. So even more, a little bit more challenging here, because I have to somehow get those bases to be common. Okay, same idea here. How am I going to get 4 to what power is equal to 1 over 64? Well, I know 4 to the third power is equal to 64, because that's 4 times 4 times 4. So 4 to the negative third power is equal to 1 over 4 to the third, which is equal to 1 over 64. So I'm going to rewrite that 1 over 64 in terms of 4 to the negative third. So I have 4 to the x plus 1 is equal to 4 to the negative third. Set the exponents equal to each other. X plus 1 is equal to negative 3. Subtract 1, and we're going to get x is equal to negative 4. So you have to know those negative exponent properties, because they're going to be really, really important here. And you have to be comfortable with rewriting things that are negative exponents and getting to that spot that you can be comfortable with. Remember, the key thing here is, though, that you have a common base. Don't want red. We have a common base here of 2. We have a common base here of 4. Once you get them to be a common base, then all you have to do is set the exponents equal to one another. Got a bunch of try these that we're going to do in class. I'll see you then, guys.